This is a research methods video on experiments, different types of experiments. If I can just remind you as you listen to this video to write the Cornell notes as best you can and also answer the questions that I'll ask as we go through the video. Once you've finished, write this up as neatly as you can into your mind map and have a little look through some of the additional textbooks. Okay, so let's have a little look at some experimental types. The first and most familiar to you is probably a lab experiment. So this could literally be a laboratory in which participants will come to you. And you try and imagine this situation. So you've signed up to take part of a psychology experiment. They send you a letter in the post. It says, come to this place at this time. So you get on the bus and you go to see a researcher at this university building. It's all a bit new to you. Keep that in mind because that's going to inform some of our ways of evaluating what's good and bad about a lab situation. The key point of a lab experiment is it doesn't have to be a laboratory, but it does have to be in a situation where you can control as many variables, as many things that could potentially change as you can. That means you'll also want to have some standardized procedures as well. So you do this, you do this, you do this, you do this. You're completely in control of the situation in a lab study. Okay, so let's evaluate this. What's good about it? Well, because you're controlling the experiment so carefully, it means that any change that you do observe should be due to the change you're making. Okay, so the change you're making is the independent variable, and then the dependent variable is the change is what you see observed. So this type of experiment should have very high internal validity. Also, you're able to write down exactly what you've done, give it to another researcher, and they can repeat it. And if they find the same results, that's great. So these findings should be highly reliable. So because we've got such a high control of extraneous variables, what we can say is we've observed a cause and effect relationship between what's known as the independent variable, which is what we have changed perhaps between two groups, and that's effect on the dependent variable, which is what we're going to be measuring the change in. So one advantage of a lab experiment is we can state cause and effect. Problems though? Well, in a lab experiment where you're conducting the research yourself, it's very easy as an experimenter to slightly, maybe unconsciously or consciously, manipulate the research that you're doing and influence the outcome. This can be fixed, and later in a later video we'll talk more about a process called double blind, where the participant doesn't know what's going to happen to the experiment, but also the experimenter doesn't know what's going to happen. They're conducting the research on behalf of a separate experimenter who has designed the study. Okay, some problems though. Well, if you're basing this in a lab, remember I told you to imagine you're going to a university, you've never been there before, it's new buildings. This is outside of your general comfort zone. This is a unusual situation. You might perform in the lab in a way very differently than you would perform in real life. So what we might say is that, okay, well, it has high internal validity. You've in the lab, this is how you would perform, but we can't apply this more generally to life outside of the lab. So we might say, because we can't generalize this, it has low external validity. And also, when you're sat there as a participant, and I've been in a few studies myself, you cannot help but think, okay, well, what does this researcher want from me? And how can I perhaps give them the results that they want? Now, this is called a demand characteristic, if you can work out what the researcher wants and try and help them out with it. Okay, a question on lab experiments. What I'd like you to do is have a little think back through the course so far and list as many lab experiments as you can and have them ready for class. Next type is a field experiment. So this is an experiment which isn't in the lab. It's conducted in a school, perhaps, or a hospital, or wherever is most relevant for the research. You can imagine these environments are a lot more messy. There are a lot lots of people moving about, lots of distractions and that kind of thing, but perhaps a place where people feel more comfortable, perhaps where people spend most of their time in day-to-day life. So you can probably pre-guess some of the evaluations we're going to have. The independent variable is still manipulated by the researcher, though. You might have two groups and you'll be making a change, and then you'll be trying to judge the results of that. So the researcher is the person actually making the change. Okay, so a big benefit to this. Well, this is done in a real life environment. The setting is real life. So that means that we have higher ecological validity, where the situation is like that in real life and can be generalized to other real life situations. Problem, of course, is we don't have much control over extraneous variables. You can have people moving in and out of the room. It can be quite noisy. So we could argue that any change that we do see isn't due to the independent variable we've changed, but some other extraneous variable that's actually produced the results. Before we move on, what I'd like you to do once this video is finished is I'd like you to try and find an example for me of an interesting field experiment that we don't cover in the course, and we can talk about that in class. So perhaps just a very quick Google search. The next one we'll talk about is a natural experiment. Now, natural experiments, they've kind of already happened. So the change in independent variable, this has already happened naturally. It's not being manipulated by the researcher. So one interesting example might be, say, twin studies, where you have two children and they've got exactly the same genetics if they're monozygotic twins. They are split up and they then have very, very different upbringings. They have very different nurture effects. Now, you could never do that intentionally. You could never just go in and split these twins up at birth. But because it happens naturally, because this independent variable of nurture has been changed, then we can go and observe these twins. Okay, so it's very high in external validity because these changes have happened naturally. These has happened in real life. It's not manipulated by the researcher. The researcher is just coming in and recording the data that's already out there. Because of that, there are no demand characteristics. These are people's real lived lives. Problems, though, we have no control whatsoever over extraneous variables, and we might not even know that they're there when we take our data. And also, completely not replicable. These are situations that happen because we don't have the funding to do it, or we couldn't ethically do it, so we just rely on these things just turning up. Quick question on natural experiments. I'd just like you to make some suggestions of things that would be quite interesting to look at with twin studies. So if you can separate twins from birth, what things might be interesting to study between these twins? Okay, and now the last type of experiment. Now this type of experiment can actually fit in any of the previous groups, but it is a little different. With a quasi-experiment, your change in your independent variable can't be manipulated or randomly assigned. So usually you'd get your participants in, you'd split them into maybe two groups, and you'd maybe do that randomly or through some other method. But we can't do that for quasi-experiment. So if you imagine if you're looking at gender differences between males and females, you can't have your participants come in and go, well, actually, okay, you guys are going to be male today and you guys are going to be female today, or same with old and young people. They already come in those groupings. So when we do these experiments and we say we've observed a change due to, say, gender, we don't really know if it's due to gender, or perhaps it was due to some inherent factor about other differences between males and females. Maybe the education system between males and females is slightly different, and that's resulted in the change. And it's not ultimately due to just being a male or just being a female. Of course, this is the only way to study gender differences. There's no way getting away from the fact that it will be a quasi-experiment if we're looking at gender differences, because we simply cannot randomly assign genders. And we can't control participant variables as R negative. So, as I said, there might be issues between these groups, that vary for some other factor, and we simply can't do much about it. So I've given you examples of male and female and old and young as groupings that are going to come to us in perhaps a laboratory already set up. I'd like you to come up with 3 other potential quasi-experimental groups. So male and female is one, old and young is another. Try and think of another one. Okay, that's it for this video.